Hey, so there's a cool new Starknet update that just rolled out, and in this video we'll get into it. Today we'll talk about the v0.13.2 update, which includes parallel execution and block packing. But first, let me ask you this. Remember when you had to wait in line to get your lunch in your middle school cafeteria and how long it took just to get a hold of your meal? Well, this is kind of how blockchains work at the moment. What I mean is that blockchain transactions are processed sequentially, one by one. Each one waits their turn to be processed. And just like you hated the feeling of waiting for your lunch in line, trust me that every transaction hates the feeling of waiting to get processed. Luckily, the new update on Starknet allows for transaction processing time to speed up. It's parallel execution, and it now processes multiple transactions at the exact same time. For example, let's say that you're playing the game Loot Survivor and that you just attacked a dragon. At the exact same time that you attacked that dragon, Alice sent some ETH to Bob. Now these two transactions, they can be processed simultaneously because the fact that you attacked that dragon has nothing to do with the fact that Alice sent some ETH over to Bob. So there's no need for one transaction to finish before starting the other transaction. Okay, so now comes the most interesting part of the video. What does this update have to do with you, the users, and the developers? Well, all you need to remember is that Starknet is now way faster. Parallel execution is an update that is added to the Starknet core protocol, so all your transactions benefit from this update seamlessly. Now, the update number 2 of v0.13.2 is what we call block packing. It's a cool new feature allowing for more frequent blocks and optimizing for gas consumption. So, what is block packing actually solving for? Currently, all Starknet L2 blocks have an L1 fixed cost that is associated. And if we want more frequent L2 blocks, we'll have to pay more of those L1 fixed costs. And to solve this, we introduce block packing, a feature that increases the frequency of Starknet L2 blocks without incurring more L1 fixed costs. In other words, we have decoupled L2 block frequency with L1 fixed costs. And this is possible thanks to a cool new data structure that is called a SNAR tree. The leaves of the tree are Starknet blocks, which represent the state transitions of the network. These are continuously merged together at each level of the tree until we get the tree's root, which represents the merged state transitions of all the blocks. Now, all we do is send this root over to Sharp, which creates a Stark proof, and then we send this proof over to the base layer so that it can be verified. And just like parallel execution, this is an update at the Starknet core protocol level, so you're probably going to experience the changes seamlessly. Now, that's all for v0.13.2. If you have any questions, post a discussion on the forum, send a Discord message, or just shoot me a private message on Twitter, and I'll see you in the next one.